In this lesson we're going to look at more uses of the discriminant, but before that I'm just going to look at this idea of solving quadratic inequalities. It's important and it comes up quite a lot, and it's important to note the differences between rules of solving an equation and solving an inequality. In this top line, if we ended up with 7 equals x here in an equation, we could just easily switch it around and say x equals 7. That's fine, that's okay. But when you have an inequality sign, a less than or a greater than or greater than equal to or less than equal to, this is not possible. And the reason for this is that if you're saying that 7 is less than x, then that means that x is bigger than 7. So we can't then turn around and say x is less than 7 underneath. So if we're saying that 7 is less than x, then we need to say x is greater than 7. So when you're switching round from one side to the other, you have to turn the inequality sign round as well. Another point to make, when you have this idea here of negative x is equal to negative 4 and you divide through by negative 1, then you can write x equals 4. That's absolutely fine when there's an equal sign. When you have an inequality sign, you can't do this. If we're saying negative x is less than negative 4, that means the x here needs to be 5, a 6, 7, so that you're saying negative 7 is less than negative 4. That's fine. So this x value needs to be bigger than 4. So we can't then therefore say x is less than 4. So if negative x is less than negative 4, then when you're dividing through by negative 1, you've got to say x is greater than 4. You switch the sign around. Two important points to note to keep yourself right when dealing with inequalities. Okay, let's look at this example. We can use the discriminant to find unknown coefficients in a quadratic equation. The unknown value here is p. So it says find p given that 2x squared plus 4x plus p is equal to 0 has real roots. So first of all, get your values of a, b and c for your discriminant. So a is 2, b is 4, and in this case c is this value at the end here. So c is equal to p. Now for real roots, that means they exist, and b squared minus 4ac needs to be greater than or equal to 0. Because if it's equal to 0, the roots still exist, there's just one of them. And if it's greater than 0, there's two of them, so it's greater than or equal to 0. So now we can set up an equation. We've got b squared is 16, take away 4 times 2 is 8 times p, so 8p. Take the 8p over the other side to make it positive. Divide by 8 and then switch around so p is less than or equal to 2. So the equation has real roots when p is less than or equal to 2.